So let's give another one a shot. Sometimes we're really, really lucky, and we're actually given a formula that we can use to find a maximum or minimum for a function. So on this one, we're given this function. This is dealing with the flow rate of cars on a congested roadway, and it's given by the formula F, which is our flow rate, is equal to V, the velocity or the speed of the traffic in miles per hour, divided by 22 plus 0.02 times V squared. What speed will maximize the flow rate of the road? Well, the nice thing is that, well, we already do have a formula, so all we have to do is try and see where it leads if we try taking a derivative. Remember, if we are given some, well, we are given some practical problems right here. Of course, V equals 0 is the minimum. And one thing that we really should be doing whenever we're writing these functions is establish what the domain is, right? And right now, we know that the slowest speed we can have is 0, right? And the traffic can just be completely stopped. But that's not going to be an optimal flow rate, right? How about the top speed? Well, we're probably limited by the top speed of the cars that are actually on the road, but for the purposes of our demonstration, we would have to say that unless we find a place where this becomes 0, and the denominator is not going to be equal to 0, right? You recognize that if we were to set the denominator equal to 0, we'd get a v squared equal to a negative number which has no real root. So our domain, we're just going to say, well, infinite speed, right? We can go as fast as we want in an ideal world. Clearly, that's not going to be the case. We might even say, people go 70 miles an hour or something like that on average or something like that. But what we're going to do is we're going to just take this to be our domain. So 0 to infinity, right? That's the realistic limits on our velocity, our speed in miles per hour. So what could we say? Well, we're going to have to take our function and find the derivative f prime in terms of v. Well, that's a job for our old friend, the quotient rule, right? And remember that the quotient rule stated that we take the derivative of we take the denominator squared. So we're going to take 22 plus 0.02 v squared, quantity squared. And it is the denominator, so 22 plus 0.02 v squared times the derivative of the numerator, which is 1, minus the numerator times the derivative of the denominator. The denominator, 22, that's a constant. Its derivative will be 0. And it will be 2 times 0.02, so 0.04 v as the derivative of our denominator. So we just need to simplify that down. F prime is equal to, let's see, 22 plus 0.02 v squared minus 0.04 v squared divided by 22 plus 0.02 v squared, quantity squared. Simplify one more time. F prime turns out to be 22 minus 0.02 v squared divided by 22 plus 0.02 v squared, quantity squared. Fun function, I know, but a couple of things that we can say. First of all, f prime is undefined nowhere. And again, we state that without really proving it, but because the denominator has no real roots. So what we're going to do is we're going to say, well, f prime would be equal to 0 at the point where the numerator is equal to 0. So at the point where we find the solution to our equation, 22 minus 0.02 v squared is equal to 0. So let's come over here and let's work that out. What does that mean? Let's see. If we isolate v squared, we're going to get 22 is equal to 0.02 v squared. So we would divide both sides by 0.02. Divide by 0.02. That's kind of like saying over 2/100ths, right? And if you work that out, that's like saying 1100 is equal to v squared. So what we should do is get out our handy dandy calculator. We can only use positive roots, so we're just going to take the positive root of 1100, and we're going to have to approximate right here. So I'm going to approximate this to the nearest hundredth of a mile per hour, and if I work that out, v will be equal to 33.17 miles per hour. So this could be what it is. Now, of course, I sometimes need to go through and verify that that is a minimum. And of course, the way that I would do it is I would just say, well, f prime is equal to 0. I could take the second derivative and figure it out. I could also go through and find out where there's a sign change. I would find that this is a minimum, however. I'm sorry, this is a maximum, pardon me, for the function. If you start substituting in values that are higher or lower, like if we put in 0, obviously we're going to get 0. If we put in a faster speed, try 55 miles per hour for v, you're going to find you're going to get a lower speed. So this is our maximum speed right here. And we're done.